Welcome back. Let's talk about section 10.2. So in this section, we are going to talk about similar figures. So our objectives are to write similarity statements, statements of proportionality, to figure out which parts of the figures are congruent, to figure out scale factors, and to figure out missing side lengths. So first of all, you need to know the difference between congruent and similar. So in geometry, when we say that two figures are congruent, we mean that they are identical. They are the same shape and they're the same size. But similar figures aren't identical, they are similar. They are the same shape. But they don't have to be the same size. So in order to be similar, their corresponding angles are the same. Their corresponding angles are congruent. If you look down at these two quadrilaterals, if you measured how wide angle A is and how wide angle E is, they would be the same size, exactly the same size. The angle opening, the measure of the angle is identical. Those two angles would be identical. I could superimpose the corners on each other and the corners would be the same. And same thing for angle B. Angle B and angle F, if I got out a protractor and measured them, they would be the same size. Same for angle C and angle G. And same for angle D and angle H. So the angles are congruent to each other. The angles aren't similar, the angles are congruent. But the sides aren't the same lengths. What the sides are proportional. So the lengths of the corresponding sides are proportional to each other. So what that means is that they all have the same ratios. I'm going to mark the corresponding sides here. So I'll do this one in blue, this one in pink, this one in green, and this one in yellow. So if this blue side is twice as long as this blue side, that means that this pink side has to be twice as long as this pink side. And this green side has to be twice as long as this green side. And this yellow side has to be twice as long as this yellow side. They all have to be twice as long. I can't have this blue side being twice as long as that blue side and this pink side being 1.5 times as long as that pink side, and this green side being 3 times as long as that green side. They all have to be the same ratio. So it's like when you have a picture and you take the corner and you drag it. Let me pull up another window and I'll show you what I mean. Right now I've got 2 lightning bolts and currently they are congruent. They are exactly the same size and shape. So if I take this one, I'm going to drag the corner, and I'm holding down the shift key, so I am telling my calculator to keep them similar. So I'm dragging this, and see how it's changing. It's keeping the two similar. So if you look at it, all of the angle sizes are staying the same. None of these angle sizes are changing. And the sides are all changing in the same ratio. I don't have one of the sides getting twice as long while the other side gets 3 times as long. They're changing in the same ratio. So this is similar figures. But I can also make this be not similar. So if I don't hold down the shift key, I can do something like this. So in this case, the width here, this length right there that I'm pointing at, that got maybe 3 times as long, while this side hardly got longer at all. So the width was changing a lot, but the height was not changing. And when I dragged it that way, the angle sizes, how wide that angle right there is, changed a lot. And this angle right here is a lot different from that angle right there. So similarity keeps this angle and that angle the same. And it makes all the sizes change proportionally. So the sizes are all changing at the same rate. It will ask you for 2 types of statements on your homework. So the first one is called a similarity statement. So a similarity statement is telling you that the 2 figures are similar to each other. And what is really important in a similarity statement is the order of the letters, because the order of the letters tells you which angles are congruent to each other. So in this similarity statement, it's telling me that angle A is congruent to angle E, because those are the first letters. It's telling me angle B is congruent to angle F. Those are the second letters. It's telling me angle C is congruent to angle G. Those are the third letters. And angle D is congruent to angle H. So when you write these, it's very important that the orders match up. I could change the order of the first one. I could have named this BCDA or CDAB or DABC or DCBA, as long as I changed the order of the second one to match. If I had named this BADC, let's try that. BADC. I would have had to name the other one F. The second letter's A. A is congruent to E. Third letter was D. That matches H. And the fourth letter is C, so that would match G. So there's not just one similarity statement, it's just that the orders have to match. Whatever you name the first one, you need to make sure the order in the second shape matches. So the first thing it's going to ask me here is it wants me to list the pairs of congruent angles. Well, I've got the picture right here. I can certainly do that. I can also do that even if I didn't have the picture, just by looking at the similarity statement. I look at the first letters. Angle A is congruent to angle E. It's really easy to get the similar sign mixed up with the congruent sign. Remember, the shapes are similar, the angles are congruent. So that can be kind of hard to remember sometimes. The second set are B and F. So angle B is congruent to angle F. Third set, angle C is congruent to angle G. And the fourth set, angle D is congruent to angle H. The next thing is a little trickier. This one is the second kind of statement. We had the similarity statement. Now we have a statement of proportionality. So proportions are things saying that two fractions are equal to each other. Well, in this case, we have 4 fractions. And what we're going to do is we're going to say that if we take this side, AB, and divide it by its matching side, we'll get the same thing we would get if we divided the green side by the green side, and that will be the same as yellow side divided by yellow side, and that will be the same as blue side divided by blue side. So let's start with pink over pink. So side AB divided by side EF should give me the same thing as side BC divided by side FG. And that should give me the same thing. No, I don't want to write in yellow. Let's do orange instead. As side CD over side GH. And that should give me the same thing as side DA over side HE. So I want to point out some things on this. Notice that here I have AB. Well, that's the first 2 letters in the similarity statement. And underneath that, I have EF. Oh, that's the first 2 letters right there. In the second fraction, I have BC. Oh, that's the middle 2. And FG. Oh, that's the middle 2 there. CD. Oh, that's the last 2 there. GH. Oh, that's the last 2 there. DA. That's the last one and the first one. HE. That's the last one and the first one. So if you ever see a fill in the blank on a statement of proportionality, all you have to do is say, okay, what 2 letters do I have? If you have the 2 middle ones, well, look at the other shape and write the 2 middle ones in the blank. If you've got the last and the first, look at the last and the first on the other shape. One thing you need to make sure of on these is make sure that all of these come from the same shape on the top. And make sure that all the ones on the bottom come from the same shape. But all it's saying is that if you take the pink side divided by the pink side, you'll get the same thing as green side divided by green side, as yellow side divided by yellow side, as blue side divided by blue side. You don't have one of them being 3 times as big as the other and one of them being 2 times as big as the other. They're in the same ratio. Now, that fraction that you get is called a scale factor. So it is the ratio of corresponding sides. So all it is matching side over matching side. And we're not going to worry about which shape you put on top, so don't panic. But each one of these is a scale factor once you reduce it. They're all equal to each other. So they are all called the scale factor. So it really just tells you how many times bigger or smaller are the sides in one figure than the sides in the other figure. The next problems want me to do three things. They want me to decide whether the figures are similar. So to do that, I need to make sure that all of the sets of angles are matching, are congruent to each other. So I've got to have, if I've got 3 angles, I need to have 3 sets of congruent angles. If I've got 4 angles, I have to have 4 sets of congruent angles. And I also need to make sure that when I make fractions out of matching sides, all of the fractions simplify to the same thing. The next thing it wants me to do is, if I do end up with similar figures, I want to write a similarity statement. That's this one. The one with all the fractions is the statement of proportionality. The one with the squiggly line. The squiggly line, by the way, is read is similar to. So the squiggly line over the equal sign is congruent. Similar is just a squiggly. Congruent is a squiggly over an equal sign. So let's go ahead and look at these. So the first thing I'm going to do on example 1 is look for 3 sets of angles. And that's pretty easy because they're marked. So I've got angle R is congruent to angle Y. So I need to list these. Angle R is congruent to angle Y. I've got angle P is congruent to angle Z. And I have angle Q is congruent to angle X. So that's good, but I also need to test the sides. So let's look at the shortest side divided by the shortest side. Always go shortest over shortest, middle over middle, longest over longest. So shortest over shortest is 9 over 6. Reducing that fraction gives me 3 over 2. Let's look at the middle side over the middle side. So 12 over 8. 12 divided by 4 is 3. 8 divided by 4 is 2. Okay, 3 halves, 3 halves. So far, so good. We have one set left. We have longest side over longest side. So 18 divided by 12. 18 divided by 6 is 3. 12 divided by 6 is 2. So all 3 of those reduce to the same thing. That means I've got 3 sets of congruent angles and 3 sets of proportional sides. So these are similar. Now I need to write a similarity statement. So you can name the first triangle whatever you want. You can name it triangle PRQ or QPR or RQP. I will name it triangle RPQ, just because I'm feeling like not being alphabetical today. But whatever order I named that one in, the order on this one needs to match. So since angle R was congruent to angle Y, the first letter I put over here needs to be Y. And since P was congruent to Z, the second letter I need to write here needs to be Z. And since Q was congruent to X, I need to write X. So the order on the second one needs to match the order on the first one. Now the last thing it wants is the scale factor. Well, this is your scale factor. So whatever you get when you reduce those fractions is the scale factor. What that means, 3/2 or 1.5, what that tells me is that the sides in this first shape are 1.5 times as long as the sides in the second shape. So now we're going to look at example 2. So in example 2, I've got two rectangles. So the angles are pretty easy. All of them are right angles. So right angles are all 90 degrees. I can just write all right angles are congruent. So obviously the angles are good. All of the angles match up, but I need to test the sides. So let's do the shorter side of the rectangle divided by the shorter side. So I have 9/6, which is 3/2. Boy, I really like 3/2 today, apparently. And the longer side over the longer side is 12/10. Well, those can both be divided by 2. That gives me 6/5. And 3/2 and 6/5 are not the same number. 3/2 is 1.5, 6/5 is 1.2. 1.5 and 1.2 aren't the same. So if these are not the same, that means that those two shapes are not similar. So it doesn't matter that the angles are all the same. If you have sides that aren't proportional, that means that the figures are not similar. So don't write the similarity statement or find a scale factor if they're not similar. The similarity statement and scale factor don't exist. Some of you may find that your head hurts when they're rotated like this. So I really like to color code. If you've got some colored pencils, I find that can be really helpful. It does help that the angles are marked here, but I'm definitely going to do some color coding. So I have angle B is congruent to angle G. Let's see, the ones with 2 marks, I've got angle A is congruent to angle F. Three marks, I have angle D is congruent to angle E. And 4 marks, angle C didn't come out very well. Angle C is congruent to angle H. So now that's color-coded, I can kind of wrap my head a little bit around what's going on. And I can also get an idea of the sides. So I'm not going to highlight the sides, I'm just going to kind of look at it here. I will highlight the sides. So I've got the shortest side, 7, over the shortest side, 5. That doesn't reduce, so I'll leave that how it is. I have the next longest, 14, over the next longest, 10. Those can both be divided by 2, and that gives me 7 over 5. Okay, so far so good. I've got the next longest, 21, over the next longest, 15. If you get confused, notice I was going from the angle with 4 marks to the angle with 3 marks. This is the angle with 4 marks, this is the angle with 3 marks. So that kind of helps you figure out which side to look at, between 4 marks and 3 marks, between 4 marks and 3 marks. Oops. So 21 over 15, those can both be divided by 3, that's 7 over 5. And the last one, whoops, not what I wanted to do. The last one is the longest side over the longest side. 28 over 20, those can both be divided by 4, and that gives me 7 over 5. Oh, look, they're all the same. So just to make my life a little simpler, I'm just going to name it in the order I've got the letters already with the angles. So I'm going to name it B, A, D, C is similar to G, F, E, H. Yeah. And the scale factor is 7/5. Next type of example, you are going to have 2 figures and it will tell you they're similar. So it gives you the statement, triangle ABC is similar to triangle XYZ, and you're going to need to figure out how long a missing side is. So what I like to do when I see the statement is mark my matching angles. Angle A is congruent to angle X. Angle B is congruent to angle Y. And angle C is congruent to angle Z. That helps me when the shapes are rotated to figure out which sides match up with which. So in order to figure out what X is, I need to find 2 sides that match where I know both sides. So I have a choice here because I know the side between A and B between 1 mark and 2 marks. I also know the length here between 1 mark and 2 marks. So I could use the 15 and the 9, but I also know between 1 mark and 3 marks. I know the 20 and the 12. So it's up to you which of those you use. I'm going to go ahead and use the 15 and the 9 because they're smaller numbers. It doesn't matter which shape you put on top, but put the same shape on top in both fractions. So I'm going to do 15 over 9. So I'm doing big shape over little shape. And that will equal, now I want to figure out what X is, so I'm going to have X here, and which side matches X, the one between 2 marks and 3 marks. So that will be 6. Cross multiply. 9x equals 15 times 6 is 90. divide by 9, and you get x is 10. That one was a little harder because it was rotated around. Sometimes it's not as hard. Sometimes you can just see, oh, all of these sides are double these sides. And you can do it by looking. Sometimes, though, you really need to mark the diagram. So same, ABC is similar to XYZ on this. So A is similar or is congruent to X. B is congruent to Y, and C is congruent to Z. So again, I've got my pick. I always try to stick with the lowest numbers I can. So between 1 and 2 marks, I've got 3. Between 1 and 2 marks, I've got 6. So I'll start with that. So 3 over 6 equals X is between 2 marks and 3 marks, so that goes with 10. So cross multiply 6x equals 30, divide by 6, divide by 6, you get x is 5. And you might have realized on this one that, oh, 3 times 2 is 6. 4 times 2 is 8. What times 2 is 10? You might have just figured out that that was 5. And that's totally fine if you did. Some people are better at visual reasoning than others. And if you can do that, that's great. There are definitely other ways of thinking through this. Okay, this one is one where I really need marks. This rotation makes my head hurt. If I didn't mark the angles according to the order of the letters, I would definitely get things wrong. So I look at the order. F and P are the first letters. So F and P are the same. Well, I know how big P is. P is 81 degrees. That tells me that F has to be 81 degrees. Cool, extra info. G and Q are the same. And, oh, hey, G is 144 degrees, so Q must be 144 degrees. H and R are the same. Oh, look, R's 45 degrees. So H must be 45 degrees. And J and S are the same. Oh, look, J is a right angle. That means S is a right angle, 90 degrees. So right now I know how big every single angle is in that figure. Now it wants me to list all the congruent angles. So I'm not going to put the numbers, I'm just going to write angle F is congruent to angle P. Angle G is congruent to angle Q. Angle H is congruent to angle R. And angle J is congruent to angle S. Now, a statement of proportionality is about how long the sides are. And it's saying all of these side lengths are in the same ratio to all of these side lengths. If I divide this side by its matching side, I get the same thing as this side divided by its matching side, which is the same as this side divided by its matching side. So I need to figure out which ones are the matching sides. So I look at which angles they're between. So if I look at the one between the 1 mark, the 81 degrees, and the right angle, that matches the one between the 81 degrees and the right angle, the 1 mark and the right angle. So those two match. And if I look at this one up here, between the 1 mark and the 2 marks, the 81 degrees and the 144 degrees, those match. And between 2 marks and 3 marks, 144 and 45, those match. And between the right angle and the 45 degrees, those match. So that's one way to do the statement of proportionality. The other way is to ignore the shapes completely and just look at the order of the letters in the similarity statement. You can just say, okay, first 2 letters over first 2 letters. FG over PQ. Well, that's just pink side over pink side. Equals middle 2 over middle 2. GH over QR. Well, that's just green side over green side. And that equals last 2 over last 2. HJ over RS. Well, that's just yellow side over yellow side. And that equals last and first over last and first. JF over SP. And that's just blue side over blue side. So all I'm saying is that these sides, when I divide one by the other, I get the same thing each time. Now I want a scale factor, so I can pick any one of these where I know both numbers. So if I look at blue side over blue side, I've got both numbers. But if I look at yellow side over yellow side, I'm missing one of those. Green side over green side, I'm missing one of those. Pink side over pink side, I'm missing one of those. So I need to look at blue side over blue side. So that gives me 9 over 6. I think we've seen that a few times today. We've had 3/2 as a scale factor about 3 times already. The scale factor is 3/2. That means all the sides in the bigger figure are 1.5 times as long as the sides in this figure. Okay, now I've already marked the angles, so I can go ahead and just answer these questions based on the angle measures I've already written in there. So angle F was the same size as angle P, 81 degrees. Angle H was the same size as angle R, 45 degrees. Angle Q was the same size as angle G, 144 degrees. And angle S was the same size as angle J, 90 degrees. If you didn't mark the diagram, look at where the letter is in the statement and say, okay, S. S matches J. How big is J? J is 90 degrees. Now to figure out the missing sides, use this scale factor, this 3/2 or the 9 over 6, and set up equations. Be consistent about which shape you're putting on top, and just remember, put the same shape on top each time. So if I want X, I could do 9 over 6 equals, well, which side matches x? The 18 matches x. So blue over blue equals yellow over yellow. I put the bigger shape on top each time. So that gives me 9x equals, let's see, 144. Which is going to equal 12. No, I did that wrong. 6 times 18. Okay, calculator. 108. That makes more sense. Which means x is 12. I knew the answer was going to be 12 because 9 times 2 is 18. So 6 times 2 has to be 12. But I was having trouble multiplying. Okay, the value of y. So y is a pink side. So pink over pink, y over 10 equals blue over blue, 9 over 6. And it doesn't matter which fraction is on which side. Just make sure it's big shape over big shape equals big shape over little shape equals big shape over little shape. So y times 6 is 6y, 9 times 10 is 90, divide by 6, and you get 15. Last one is z. So z over 7 equals 9 over 6. Green over green equals blue over blue. So you get 6z equals 63. Divide by 6. Z equals, both can be divided by 3. That gives you 21 halves, or 10.5 if you want a decimal. Either one. Oh boy. Expect me to draw a car and an elephant. That could be scary. Okay, give me a second. All right, here's my beautiful artwork. You can sort of tell that that's supposed to be an elephant. That's probably the best one I've ever drawn, scarily enough. So we have a 6 foot 5 inch foot, I can't talk. You have a 6.5 foot tall car. And its shadow is 33.2 feet long. This drawing is not to scale. The elephant casts a shadow that is 51.5 feet long. And we want to know how tall the elephant is. So you already solved some of these in the last section. So there are lots of ways you can set this up. You can do elephant over car equals elephant shadow over car shadow, or elephant over elephant shadow equals car over car shadow. Any way you want to do this is fine. I would probably go for elephant over car equals elephant shadow over car shadow. But it is up to you. So that gives me 33.2x equals 6.5 times 51.5, 334.75, divide by 33.2, you get x is about 10.1 feet tall. Big elephant. Actually, I don't know how tall elephants usually are. May not be bigger than usual. Okay, telephone booth. Back in the day of Superman, when he needed to go change from Clark Kent to Superman, he'd go duck into a phone booth, which was like this little box on the side of the road that you could stand up in, and it had a phone in it. Kind of crazy. So we have a phone booth. I'll label it. And on the wall, it had a phone. And it was one of those weird ones with like a cord that hooked it to the wall. That's beautiful. Okay, the phone booth is 8 feet tall. And its shadow, we're really interested in shadows today for some reason, is 4 feet long. Okay, lawn ornament. We're talking lawn flamingo, lawn gnome. I don't know. I'll draw a little lawn gnome guy with a pointy hat. It will be the worst lawn gnome ever. Stick figure lawn gnome. There we go. Stick figure lawn gnome. We don't know his height, but his shadow is 2 feet long. Now, you guys could probably figure this out just by looking, because, hey, look, to get from 4 to 2, divide by 2. 8 and x, divide by 2. He's 4 feet tall. But if we want to be proper about it and set up a proportion, 8 over x equals 4 over 2. 4x equals 16. So x is 4 feet. The end.